It looks like what?
Because the cue was changing.
It looks like it's changing because the light and the string are slightly off. But so if you picture it again, if you have the light on the string at the top, then the light goes off. You can't see the string anymore until 1/60th of a second later. And 1/60th of a second later, where is the string? It's back on top. So if we can match these perfectly, the only time you would ever, and get this light out of here, the only time you would ever see the string is when it was on top. So it would look like it was standing in the same place.
Why is he doing that?
Well, as you guys saw, that as I was changing the frequency of the strobe light, you saw the line, it moving faster and slower, right? So if I do this, right, more parts, the wave is illuminated more often through its cycle. But as soon as I do this, because the frequency is lower and closer to the frequency of the wave.
Well, now it's off. See, if it's not quite right, that means they're at kind of odd intervals between each other. Odd
Like
ratios.
this, I have it pretty close to the frequency of the wave, and so it looks like the wave is moving much slower because when the wave is at this spot, that is when when this light is actually shining on it. Have you guys ever done like flip books? Like you draw a circle on a page, and then you just kind of flip through, and you see kind of the circle just moving. Yeah, like a ball bouncing. You can think of it in a very similar fashion. That everything is just like a series of frames where the wave is in a different spot. This is kind of like the paper you're writing it on. Every time you flip a page, you're stopping on a different image. Does that make sense to you guys?
Yeah.
So,
cool?
Yeah.
Yeah.
I know, right? I read it. It looks like they